In this video, we are going to begin our lecture and discussion on seismic loadings that could be induced on a structure. So let's go ahead and take notes on this first sentence. Earthquakes cause vibrations that induce additional loads in a structure. Earthquake engineering encompasses aspects of geology, geotechnical engineering, structural engineering, and many other fields. Okay, so this is the idea about behind seismic loads is that when an earthquake happens, you basically have a fault that ruptures and releases a massive amount of energy that causes vibrations through the soil layers up to the ground surface, and then thereby causing your structure to vibrate, which creates additional loads within the structure itself. Okay, so how do we account for this? Well, we're going to say the equivalent lateral force, which we call this the ELF. Some people affectionately call it ELF method. The ELF method allows us to represent the seismic force on a structure as a set of static point loads acting horizontally at different story levels. Additionally, a horizontal base shear force is developed at the foundation level. Okay, so you want to take a look at I'm going to say see figure 416 in the text. So you want to have your textbook open as we go along this. Okay, so so basically, let's say we have a structure. Okay, I'm gonna just make it a building structure like this. Let's say we have some different, heights here, and we'll maybe call this, height 1, and height of this next level is H2, and then, maybe the height of this top level is H3, okay? And so what we do is we represent a structure. In this case, I'm drawing a frame. But what we do is we represent a structure as what's called a lumped mass system. So basically what we do is we take our structure, which looks kind of like a frame here, what I drew here, and instead of drawing it as a frame, we lump each story level into a single mass. So we'll call all of the loading on this level, M1, or maybe a weight, W1, W2, and W3. So the way we represent this as what's called a lumped mass system is the following. We would show this simplified view of the frame, and we would have this lump right here, which has a weight of W1 and then you have this other lump here, which has a weight of W2, and then you have this weight up here, which has a weight of W3. Now, these are going to be dead loads, okay? These are dead loads. And then, of course, you still have an H1, an H2, and an H3 as your story heights here. Now, at the base, we have a base shear, okay? We mentioned that earlier, a base shear force, call it V at the foundation level. So we call this base shear, okay? And then at each story level, we have static story forces. So we'll call this force F1, force F2, and then, you know, force F3, okay? So again, we're modeling this framed system as this thing called a lump mass system. Mass is a little, you know, maybe not the best word. You could call it a lump weight system if you want. But we represent it like this, where we still have the real heights, but we have these equivalent lateral forces. That's why we call this the equivalent lateral force method. We end up developing these equivalent lateral forces acting at the story heights along with a base shear force. So these are all, you know, this is a base shear force, and then these three right here are the equivalent lateral forces at the story levels, okay? So the question is, how do we compute all of these things? All right, so we're going to say to determine the equivalent lateral forces F sub I. Okay, so remember I just drew I drew an example of a three like a 3-story building, but it could be 4, 5, 6 stories. It doesn't have to be 3. Okay, so I'm just gonna say F sub I. So to determine the equivalent lateral forces F sub I and the base shear force V, what we do is we consider the following. We consider the site location of the structure, and then we also consider the structure itself. So what we need to do is we need to consider attributes of the site location that the structure is on. Additionally, we have to consider attributes of the structure itself. And I'm going to make follow-up videos where we talk about each one of these points. So this will conclude this introductory video.